the imaginary number I is equal to the square root of -1. So we can express now, using complex numbers, numbers that are negative inside of square roots in terms of I. And I'm writing down some examples for you. Well, that was... There we go. All right. So this is the square root of -21. Ordinarily, we wouldn't have a real number solution for it, but using the complex number system, we can write this as the square root of -1 times the square root of 21. And since the square root of -1 is equal to I, right? This is equal to I times the square root of 21. You can write it as either I in front of square root of 21 or the square root of 21 with the I after it. But make sure the I is not inside or underneath that square root symbol, because it's not part of it. So this could be written either way, technically. I noticed that a lot of the answers in your textbook had the I afterwards, so I wanted to make sure people saw that that was okay. Again, ordinarily we couldn't, actually find a real number solution for the square root of -100, but we do know that the square root of 100 is 10. So this could be expressed as the square root of -1 now, times the square root of 100. And again, the square root of the -1 is equal to I, and the square root of 100 is equal to 10. So it'd be I times 10. Here, you should probably write this as 10I. So this is negative square root of -59. Now that negative sign in front stays. I'm going to rewrite that. And now rewrite square root of -59 as the square root of -1 times the square root of the 59. It's a little sloppy, sorry. And we can make this negative I times the square root of 59. Or again, you could write the I afterwards and make it negative square root of 59 times I. All right, so either answer is acceptable. And just one last one. Square root of -28. Again, we can start off by writing this as the square root of -1 times the square root of 28. And then square root of -1, I'll make that I now, I guess. That works. You can do that in this step. Recall that the perfect square factor for 28 would be the number 4. Because 4 times 7 equals 28. So we could rewrite that as square root of 4 times square root of 7. And the square root of 4 is the number 2. So I'm going to write this as 2i square root of 7. All right. So you can simplify square roots when you can find perfect square factors like this, right? 4 and 7. You leave the 7 inside the square root, but the square root of the 4 is equal to 2. And that would be the solution.